Hey everyone, welcome to my very first episode of my devlog series, where I will be taking you along the journey as I build out apps and websites from start to finish. Within this very first episode, we're going to build an app that everyone could probably benefit from. A shopping list app built entirely using Flutter. Now keep in mind that this is not going to be a step-by-step tutorial, but rather I want to take you along the way as I figure out the requirements, the system design, as well as implement the features. So stick around if you're curious on seeing how this app is built. Whether you're a developer yourself or just want to see ideas come to life, there's a lot to explore within this series, so let's jump into the video and start building the shopping list app. Alright, so now we're over here on my computer. You can see the screen. I pulled up Excalibur, which we will be using to flesh out the requirements as well as give a little bit of a design of this shopping list app that we're currently going to build. So let's jump in. Alright, so I already predefined a little bit of the requirements, but this is essentially what I came up with, is that a user, they need to be able to create the shopping list so they can have multiples, maybe one for them, maybe one for a party or something like that. As the next step, users should be able to add and remove items from the shopping list because obviously they want to buy something. They can check off items off the shopping list. If they got it should be like crossed out or something. Items on the shopping list will be automatically categorized, so vegetables, meat, personal care items kind of have nice categories, so it's easier to find things on it. Sometimes you need multiple items, so we'll want to do account for the quantity as well. And then users can add prices, maybe. That's what I was thinking. We could probably list this as maybe, and this one as well. So the idea with the prices is that users can get a rough estimate of what they're going to be spending, but we're also not going to be updating this live, from something, so the user would have to know the cost. Sometimes unlikely, so I just put it as maybe. We'll see if we have time for that. And then users might want to access those shopping lists offline versus online, because sometimes there's no internet where they go. So those are the requirements. Out of scope, we don't want to handle collaboration on shopping lists now. Now that might be a good addition feature, but it requires basically an account and account management piece to it, which we're also going to do out of scope. In Flutter, if you use like Firebase, you could probably use the Firebase authentication for this, but for now we're just going to list it out of scope and not worry about it because it would be managed by a third-party provider. Users should not be able to scan the barcode to add items. Might be enhancement in the future again, but right now we're just building a simple shopping list app, so let's focus on the core. And then also out of scope, finding prices nearby and online orders. Again, those could be nice additions in the future if you want to take this any further. But now that we have the requirements, we can actually start building our rough system design, see how the user flow works, and then we'll get to the app. So let's build that out real quick. Alright, so now that we fleshed out the system design a little bit, here's what I was thinking. So user probably interacts with a load balancer, especially if we want to scale out that system. Then we have an item service responsible for handling the items, especially if we have items DB. Depending on this list, of course, if we have a smaller list, maybe we could store it in memory or something. But it also be possible if we, that we have a very huge list. If we have millions of items in groceries, or expanded beyond groceries to include anything that a user can buy, then probably we'll want to put this into like its own separate database, and then have something like a cache out here. We could say something like, let's say items cache. And the idea here is that, some items are probably going to be more popular than others. And if we scale the system out, then we can cache the most popular items so that users can get to those faster and we don't have to do as many database lookups. So that's one thought out here. We could partition this database-wise by items ID, especially with a relational database, so that we don't have such a huge load to the same database over and over again as we scale this out. Similarly, and more importantly, we have the shopping list service responsible for creating shopping list, also creating, adding and removing items, crossing off items on our list, and that mostly interacts with our shopping list DB. Here I kind of did a couple of examples what those databases would be storing. Within items, we would probably want to store the actual item, so be it apples, banana, potatoes, chicken, and then as well as this category stuff, fruits, vegetable, meat, so that we can link it back together. Similarly for shopping lists, we kind of need a way to store the shopping list ID. The list probably has a name as well as the items on it. So if we think from a database perspective, there are two routes that we could take. We can take relational or non-relational databases. Relational databases here kind of fleshed out like the items piece, and then we could have the item ID, the item name, and then it gets a little bit into argument. Hey, do I just want to have an ID or the category for each item? Technically, yes, it's going to be one field no matter what. I personally think it's probably easier just to toss in the category name because we're talking about one field that we need either way. And with relational databases, if I then need to group it back up again, I have to join those tables together. Versus with the category, it's just one. It'll be repeated a bit, but I think it might make sense just to have categories in here. Similarly for like list stuff, we have this list, the ID and the name. And then for the items on the list, this is where kind of the joining piece comes together, because we now have a list and we have the items. Well, how do I know which item is on the list? And because it can grow infinitely, I need to create a new table where it's kind of working as a joiner table. I can put the items onto the list and then query for that list and those items. So that's what the relational structure looks like. With non-relational, it's a little bit easier because here we can think of like, hey, I have this list, basically. It may or may not have an ID, but it certainly has a name and it has items on it. And the benefit here with non-relational is that I can have as many items as I want and need under my list. And I can work through that basically, have the name, the category, quantity, price, kind of like that for each. So, to be technically correct, I would have to do this again. Again, kind of represent that, hey, each item in my list contains of a name, a category, quantity, price, and bought. So those are basically the two options that we could go with. I think this is such a simple system, and given the relational nature, that I think a relational database works fine for us right now. But yeah, that's like the basic overview. So, if we look back on the requirements, users can create a shopping list, working through that list service, going to be stored in database. They can add, remove it through that list service, check off items on the list as well. Each item can have a quantity that's probably going to be entered on the user screen when they input the item. Yeah, and then even our maybes like prices and accessing the list offline. So prices, is just another field here in the database that's easy to store. Accessing the list offline depends how we want to kind of store this a little bit. It's definitely on the user side more so than on our database side or anything else, because it's going to be stored on the user device. If we say they can create one offline, then it already comes down to, hey, can we maybe cache those items that the users likes to add a lot on the user's end? or is there like a subset of lists that a lot of users tend to purchase a lot or add to their list a lot, so they can just put it there and then have a optional field just to add anything random, just won't be categorized, or they have to categorize it themselves. So that's another thought. If we wanted to support this offline thing, it needs to be on the user end, really, that it's going to be cached or stored. And then whenever the user comes back online, we can push it through our shopping list service into the database, so that they don't lose it. Well, they won't. Maybe they erase their data on the account or delete the app and install it again, or even if we want to expand it to collaboration with other users or something like that, we definitely want to push the user shopping list if it was created offline here, and if it was created online and then they're offline, we want to make sure we store it on the user's device. So there's not necessarily another service for this. It's just the way the stuff gets routed is a little bit differently. All right, so that is like at a high level, like our requirements, system design, where we're taking this app. And now I'm gonna pull over a diagram real quick, which I have pulled up earlier. I looked at what we're gonna be building. So I found this nice on Drupal, this nice shopping list right here. Can probably make it a little bit bigger so we can see it better. But essentially, this is what we're going to be building. Not quite 100%, what we're going to be building, but we're going to have like this sort of list here, where we can have as many lists as we want. Users can create a new list out here, and then, like I said before, we're not going to have this cart because we're not supporting online purchases, or finding items nearby. So we're not going to have this necessarily, but we're going to have this more simplified view here on the right, where they can add an item, add the quantity they need out here on the right. So yeah, this is basically like this left and this right screen is what we're gonna try to build using Flutter. And that wraps up the system design of our shopping list app. We have mapped out the flow, we have identified key features, and we have a solid understanding of what the UI is going to look like. So I'll be back next week where I will actually bring the design to life using Flutter. So be sure to subscribe to the channel and hit the notification bell so you don't miss that video. And with that, I want to say thank you so much for watching, and I will see you next time.